So, hello and welcome to these lessons where I will show you the answers and the mark scheme for the test that you did at home for some days ago. So I will show you how you are supposed to think and what you get the points for. And I have the test like this. So we will look at the questions and I will show you the answer. And the first question here was about two constants. You should determine the constant a and c, and it is a exponential function. And I think c is the most easy constant to find. It's the intersection with the y-axis, that is 1. And the constant a has to do with the decrease of the value to do, and it's the factor of change. And the most easy way to realize what it is to look on some numbers here. So you see, when we have the x value minus 1, then the y value is 2. And then it drops as you go one step to the right, it drops with a half. So from 2 to 1, that's a decrease with 50%. Therefore, a is 0.5. You can look at it here as well. Y is 4 and x is 2. And as you go one step to the right, it drops from 4 to 2. That's because 4 times a half is 2. 2 times a half is 1. 1 times a half is 0.5. 0.5 times a half is 0.25, and so on. So, on question A, C is 1 and A is 0.5, the factor of change. It's a 50% decrease for every step you go to the right. And you got 1 point for this one, and 1 C point for if you have A correct. Okay, exercise 2. There's 2 calculations with logarithms, but I write it down here so you will see it. It says 10 to the power of log 12. I start with that. This is actually 12. Log 12 is the number that you will take in exponent with the base 10 to get 12. Well, now you have this in the exponent. Therefore, this is 12. If you realize this, got this right, you will get 1 point. The other one is this, log 10. This is a number that you will take 10 in the exponent to get 10. Well, it has to be 1. If you have this right, you can get 1 point. And then you were supposed to take 12 minus 1. And then it's 11. Then you have 2 points. This is question A on the second one. Question B. Then you were supposed to find out log 2 to the power of 8, like this. Now, this in total is a number, so you will have the base 2, you will have the exponent, this number, and then it will become this number, 8. What exponent do you need? That exponent is this number. Well, this is 3. 2 to the power of 3 is 8. Therefore, this is 3. And then it was log 3, 9. The same thing here. 3 is the base, and you will have an exponent, and this is the exponent, and then it will become this number, 9. So the exponent has to be 2, because 3 to the power of 2 is 9. Therefore, this number is 2. Oops. And you were supposed to add them. If you find out what this is, you will get the first point, or this point, you will get 1 point. And if you got both right and add them correctly, and in this case it will be 3 plus 2, and that is 5. Okay, exercise 3. Let's look on that. Anita deposits 10,000 in a saving account with 1.25% annual interest. Which of the following equations should Anita solve if she wants to find out how many years it takes before the money doubles? Well, doubles, it has to be 20,000, so it can't be that one. And equation 4 is the correct answer. 1.25%, that means you have the factor of change 1.0125. That's an increase with 101.25% every year. This is 2.5%, can't be that. This implies a decrease when the factor of change is smaller than 1. And this is the year. We asked for the years, it can't be 3. Therefore, it's 4. And it's just one answer, so you need to write to get this point. Okay, exercise 4. Solve the equations. I will show you how to do that. I write them down for you. So x2 minus 14x plus 48, and that's supposed to be 0. This is the PQ formula. So x is equal to half of 14 with the opposite sign, that's plus 7, plus minus the square root of 7 squared plus the constant with opposite sign, that's minus 48. If you have done this right, you will get the first point. And now you have to solve it. So x is equal to 7 plus minus. This is 49 minus 48, that is 1. The square root of 1 is still 1. So the solutions is 7 minus 1, 6, and 7 plus 1, that is 8. If you have both these right, you get full points on this. The second equation was this: the square root of y plus 4y is equals to 0. This is a little bit harder equation. It gives you C points. So you start with subtract with 4y. So the square root of y is negative 4y. Then you will get rid of the square root. So you square both sides. Take this, and you square both sides. So we will get y. Now, minus times minus, that's positive. 4 times 4, that is 16, and y squared, like this. Now we probably have a problem, because if you square something, the negative disappears. It could be positive 4y as well. It still works. So we might have a false root now. We have to check that out later on. So 0 is equals to 16y2 minus y. You could now divide with 16 and then use the PQ formula. Or you factorize with y. Then we will have 16y minus 1. And now you use the product rule that says that if this is 0, then it becomes 0. And if this is 0, it becomes 0. So y1 is equals to 0 is one solution. And the other solution is when the bracket is 0. I will show you that here. 16y minus 1. If that is 0 and you multiply with this, well, then it becomes 0. So 16y minus 1, and y is 1 over 16. So y2 is 1 over 16. So let's find out. Is it true? So we need to check. You always have to do that when you're solving equations by squaring. So the first solution, 0. The square root of 0 plus 4 times 0, is that 0? Yes, it is. So that is true. 1 over 16. 1 over 16 and the square root of it plus 4 times 1 over 16. Is that equals to 0? Well, the exponent law says that you're supposed to take the square root of 1, that is still 1. And also the square root of 16, that is 4. Plus, and here you can divide the numerator with 4, that's 1. And divide 16 with 4, that is 4. So this is 1 over 4. 4 divided with 16 is the same thing as 1 divided by 4. Is this 0? No, it's not. 1 over 4 plus 1 over 4, that's a half. So this is not true, and this is not true, therefore. So we have one solution. The answer, y is equal to 0. Okay, let's look on the last exercise on this. It looks like this. Log for log x, brackets like this, is equals to minus 1. Well, what is this? Well, first you can say that like this. Log for a certain number, it's under my finger here, means that this is the number that 10 is going to be in the exponent to be this number. So 10, and you take this in the exponent, then you will get this number inside the brackets. That's log x. But now, this number is the same as negative 1, so this is negative 1. Now, 10 to the power of negative 1, that's 0.8, 1/10. And that's log x. And now you have to argue at the same way. So log x is the number that you will take 10 to the power 2 to get x. Well, now this number is the same as this, so this is 0.1. And now one tricky part is that you can't go any further, you can't find any good integer number or something, so you have to end here. That's why it's a point to solve this equation. I will show you very short another way to argue for solving this equation. So log x for log x is negative 1. To get rid of log, to use a function that cancel out, you take 10 to the power of log x and 10 to the power of negative 1. Now 10 and log is the inverse function, so they cancel each other out. So this and log will goes away, so you only have log x left. And then you have this. This is 0.1. Now you do the same thing again. You take this to the power of 10, 10 to the power of this, and 10 to the power of this. Now 10 to the power of 0.1 and 10 and log x cancel each other out, so you just have x. And we will have the same answer as we had before. Okay, it's a bit tricky, I understand that. Just do your best. Okay. Next question. You have the test as well, so you can look on your maybe phone or something and look at on the questions. arrange the 5 numbers in order of the smallest first and motivate your answer. So I write down the numbers and then I will tell you how to understand it. So 10 and log 2.1, log for 99, log with base 3 and 36, the square root of 2 to the power of 2, and log 2. Oops, sorry. So, which one is smallest? And so, well, let's start with this. This is the same as 2.1. Log 2.1, and we take it in the exponent with the base 10. Therefore, it's 2.1. This is a little bit smaller than 2. I know that because log for 100 is equal to 2, because 10 to the power of 2 is 100. This maybe is the hardest one. This is a number, so 3 to the power of something is supposed to be 36, and this something is this number. And we know that 3 to the power of 3 is 27, and 3 to the power of 4 is 81. Therefore, this number has to be between 3 and 4. So, between 3 and 4. This number, square root of 2 times square root of 2, that is 2. This number, well, this number is smaller than 1, because log for 10 is equals to 1, so log for 2 is smaller than 1. Okay, now I can manage. The smallest number is the ones that's smaller than 1. I can tell you this is greater than 1 also. Smaller than 2 and smaller than 1, they could be the same, but this is greater than 1. So, we start with the smallest, log 2, then comes smaller than 2, log 99. Then comes exactly 2, then comes 2.1, 10 to the power of log 2.1, and then comes a number between 3 and 4, that is log 336, like this. And you will get 1 C point if you could argue for 3 of these. If you, for instance, write this down, and if you write this down, and if you do some research, if you, for instance, got this, then you will have the first C point. If you have some argument for this and this as well and write it correct, then you get both C points. Okay, exercise 6. I will show you here. So, match the 4 curves A to D with the correct equation 1 to 6. 2 equations are left, only answers, and you got 2 points. So, if you have 2 of them correct, you will get 2 points. Now, let's start with the linear functions. Maybe they are most easy. We'll look at the linear function C here. So, you see it intersects when y is equals to 1. And the gradient, you find it if you stand on the line, go 1 step to the right, and then you have to go 2 steps upwards. So the gradient is 2. Let's see if we have any linear function with gradients 2. Well, this has the gradients 2. And the intercept with the y-axis is 1. So C is 3. The other linear function, b, the interception with the y-axis is negative 1. Okay, don't have to work anymore because we only have 1 linear function more with the negative constant here. Then we can look on this. It's a second degree equation, and it intercepts with the y-axis on negative 3. So, negative 3, we have 2 of them here. But we also see that this second degree function has a minimum point, and minimum point happens when you have a positive coefficient here. This is positive, this is negative, so this has a maximum point. This has a minimum point. Therefore, A is 2. And D has to be this one by arguing for all the others. You can test it like this as well. If you choose a value on x, like if we choose 5, then we can see that for this function the y value has to be -4. So I can put the 5 instead of x here and calculate the y value. If I do that, it would be -4. So that's also a thing you can use for every one of these. For this linear function, you can choose x equals to 1 and see it has to become 3. So if you calculate it for 1, you see it becomes 3. That's also a way to solving this. And its only answer, you can guess and get this right. Okay, let's continue with 7. Give an example of an exponential equation that has the solution x is equal to LG2. And it's an only answer question again. So I will show you here. Okay, this is 7 now. So x is equals to log 2. Well, the most easiest equation is this. 10 to the power of x is equal to 2. When you solve it, then x is equals to log 2. Log 2 means the number that you will take x, 10, and this is the exponent, and then you will get this number, and that is 2. Okay. Question 8. You can write down this as well in your notebook, and then you will remember it a little bit better. So now it's 2 hard questions here. It says on 8, this is a fact, this is true. Give an example of numbers that meet the similarity above. It's just an answer. Give examples of numbers for A and B, so this is true. So I start by writing this down. 10 to the power of A is supposed to be 0.01 to the power of B. Well, I can do like this. I can start on testing with, I see it's 0.01, so I know that if A is equal to -2, then I have 10 to the power of -2, and that is 0.01, which is true for B if B is equals to 1. So B is equals to 1 and A is equals to -2. That is one solution to this relationship between A and B. There are many of them, but this is one. I will show you on the next question the relationship. So let's look here. Determine a general relationship between numbers A and B. So let's do like this. 10 to the power of A is equals to 0.01 to the power of B. So if you have exponents with unknowns like this, a general law is logarithm both sides. So I take the logarithm of 10 to the power of A and the logarithm for 0.01 to the power of B. And then I realize I can use the laws of logarithms here. So I multiply instead with A times the logarithm of 10. Well, the logarithm of 10 is 1. And then I do the same thing here. I multiply with B and I take the logarithm for 0.01. Well, that is -2. 10 to the power of -2 is 0.01. Now, we see that A is equals to -2 times B. This is the relationship. And we can see if you first do this question, it's easy to find two numbers. So if you choose B is equal to 1, and you multiply 1 with negative 2, then a becomes negative 2. Okay, let's continue. It's one more tricky question here. It's a system of equations with logarithm. Quite many points for it also. On this was only answers, and this you have to show everything that I showed you to get this point here. But this you can get part of these full points, and I will show you how. So I'm starting with writing this down. So it looks like this. Log for x and y plus log for y is equals to 1. And log for x squared minus log for y is equals to 7. Like this. So it's a system of equation. I use the brackets like this. Okay, if you could use the logarithm laws and do anything with this, you will get the first C point. And one laws of logarithms, that is, if you look on equation 1, you have a multiplication between those. And that is the same as rewrite this as logarithm for x plus logarithms for y. And then you have logarithms for y and equals 1. If you just do this, you get a first C point. The second equation, you can use the logarithm laws to multiply with 2 instead. So 2 log for x minus log for y is equals to 7. If you rewrite the equation 2 like this, you could also get a C point. Okay, now if we look on the first equation, we see that the logarithm for x is equals to 1 minus logarithm for y and minus logarithm for y. But that is minus 2 logarithms for y, because there are 2 of them. Okay, now insert in equation 2. So the substitution method. So I insert it here. So I have 2 and then I have log x, but that's the same as 1 minus 2 log for y. And then I have minus log for y, and that is equals to 7. Now, let's find out y. So I multiply according to the distributive law, and I got 2 minus 4 log for y minus log for y, and that's equals to 7. So I subtract with 7, so I got 2 minus 7. And then I don't want negatives here, so I add with this. So I got 4 log y plus 1 log y. That is 5 log y. And this is negative 5. 5 log y. So I divide both sides with 5, and I get negative 1 is equals to log y. And then you know that 10 to the power of this number is y. But now this number log y is equals to negative 1, so it looks like this. Therefore, y is 0.1. Now we have to find x, so insert in. I can choose an equation. I choose equation 2. That is this equation. I have to start over here. So we have 2 log x minus log for y. But y was 0.1. And it's supposed to be 7. What is x? Well, what is log for 0.1? Do you know that? You have the minus sign. Well, this is -1. Why? Well, because 10 to the power of -1 is 0.1. Okay, so we have 2 log x plus 1 equals to 7. So we subtract with 1, got 6. 2 log x. We divide with 2, so log x is equals to 3. That means, no, yes, that is true. 6 divided by 2 is 3. So x is equals to 10 to the power of 3. Therefore, x is equals to 1000. This is the number that you will take 10 to the power 2, and then it would becomes x. Now, this number is equals to 3, so 10 to the power of 3. X is equals to 1000. So, answer, x is equals to 1000 and y is equals to 0.1. Okay, not that very easy. So the first point in the mark scheme is to use some of the logarithm laws to rewrite equation 1 or 2 in this case. Realize that you should use the substitution method, so you do something correct, like have log x alone and put it in the other equation. That gives you the first A point. And finding both solution gets all the points for you. Not easy, you do your best. Okay, that was the final exercise without calculators. Now you are allowed to use your calculator, and we will do it a lot. So I will show you. Starts with solving equations. It's 4 of them. It looks like this. Only answers, and you can use your calculator all the time. And I will show you how to do that. So I write down every equation. X to the power of 7 is equals to 15. That means that x is equals to 15 to the power of 1 over 7, like this. And we use our calculator. So 15 with exponent 1 divided with 7, like this, is equal to. And then it says in the question, answer with 2 significant figures. That means you will answer with 1.5. So x is equals 1.5, but it's not exactly true. It's a rounded off number, of course. So this is correct with 2 significant figures. Exercise B, it says 7 to the power of x is equals to 15. I know that x has to be greater than 1 and smaller than 2. So I use the logarithm laws. Log for 7 over x is equals to log for 15. So x times log 7 is equals to log 15. And x is log 15 divided with log 7. And x is equals to, and now I use my calculator. So that is log 15, end of the brackets, divided with log 7. And then the answer is 1.4 with 2 significant figures. 1.4. Exercise C. Looks like this. Log for x is equals to 1.5 instead. Okay, So this is a number, and you're supposed to take 10 to the power of this number, and then you will get x. Now, this number is the same as this, of course, because they are equal to each other. Therefore, you write 1.5 here, and you use your calculator. So x is equal to 10 to the power of 1.5 equals 2. Two significant figures, that is 32. 32. And the last one, C. It says log for 5x is equals to minus 2x plus 1. Now, this is tricky for you. So let's first try to use algebra, see if we're getting somewhere. So I do like this. I want to take away log, so I take 10 to the power of log 5x is equals to 10 to minus 2x plus 1. So these are cancel each other out. So 5x is equals to 10 to minus 2x plus 1. And I didn't come any closer to any solution because now I have the x in exponents. That's a problem. So I can't get anywhere. But I have my calculator. I can use that. So I will do like this. I will draw on y1 log 5x, the left side of this equation. And on y2, I will draw the right side, minus 2x plus 1. And I will look for the intersection. And as a matter of fact, I could do it all the time here. I can draw this on y1 and this on y2. This on y1 and this on y2. And always look for the intersection, if I'm allowed to use the calculator. So let's do that. Y equals 2. I have some old stuff here. I take that away. And then on y1, log 5x, end of brackets. Enter. Minus, and that's a negative number, so I need to use this minus sign, the negative sign. 2x plus 1. Let's see what we get. Graph. Oh, a very bad window here. The most easiest way, well, there are a couple of ways, but you could use the zoom here to choose another window, or you could use the window. But in zoom, you have two good options. You have standard. And if you go a little bit further down, you have zoom fit. That Windows is supposed to, well, the calculator is supposed to find the best window for you. So I use this and see what's happening. Enter. So the calculator thinks for a while and then starts to analyze this. And now let's see what's happening. Oh, so we have the logarithmic curve right now. You hardly don't see it. And this is the linear function, negative 2x plus 1. And I want to see the intersection between them. So I have to calculate it. I press blue and trace. And then I go down to intersect and press enter. First curve, there is only two curves, so I just press enter. Second curve, well, it has to be that one. I press enter. And guess, well, I hope it's just one intersection here. Then you just press enter. And the answer will be, after a little while, that x is equals to, and with two significant figures, it's 0.37. No, I said 7, but right 6. 37, like this. Now, let's see if it's true. We can check it with our calculator. So, let's do like this. Log 5 multiply with x, and that's 0.37. 0.37, end of brackets, enter, 0.26. And the right side of the equation, minus 2 times this number, 0.37, plus 1. Answer. That's 0.26 as well. You see, there are many more digits here, but that's close enough. This is the correct answer. And it was only answered here on this. Okay, exercise 11. It's about Emil in Lönneberga. He has climbed up on to the roof of the cattle farm. From there he shoots a rock into the air with the help of a horse bell, slangbella. The stone leaves the horse bell 6 meters above the ground. The formula for the height of the stone above the ground is h of t is this, where t is equals to time in seconds and y is in meter. After how many seconds the stone reaches its highest height, and what is that height? Well, I will show you. So this is the function for the height, depends on the time. 6.0 plus 24t minus 5t squared. Well, to find the highest height, you could do it in 2 ways. The hardest way is that you find the roots when you say that this is equals to 0. You say this is equals to 0 and you find the root. If you do that, you will get the first C point. And the roots will help you to get the symmetry line x sym. Well, now it's the time, so it should be time sym. The symmetry line is between the roots, so x1 plus x2 divided with 2. If you do that, you will get the second C point. And if you insert this value in the original function, then you will find the highest point and the correct answer. And then you will get the A point. But you could use your calculator to solve this problem. So I will do that. I take my calculator and I go into y equals, and I will draw this function so we see it as a graph. Take away these old things. 6 plus 24t, but now we use x, minus 5x squared is equals 2. And then I press, now let me see, I have to choose a better window now, and this is a very hard exercise for me. So no negative times, x is the time, so I start with 0. Now, how long can a stone or a rock be in the air? Well, not for 24 seconds, so I choose 5 seconds. Could be in the air for 5 seconds maybe. Now, it don't falls below the ground, so I can start with 0. Now, the height. What height can the stone reach? That's the question. Well, I don't know. So I choose a very high value. Well, 50 meters is quite high. If that's not good enough, I can go back here if I don't see the graph. But let's press graph and see what's happening now. So that's a perfectly parable for the path of the stone in the air. And you're supposed to find the maximum height. And you know how to do that. You have to calculate it. So you press the blue and trace to calculate. And the maximum, we go down with the arrow to the maximum and press enter. Left bound, we have to be on the left side of what we think is the maximum height. So I go with the arrows to the left. I can stand anywhere to the left on this position and I press enter. And it asks for right bound, so I have to go to the right of the maximum value. So somewhere here to the right, and I press enter. And guess, well, it's just 1 point here, so I just press enter. And the answer will be that x, or the time actually, so now I write t as in time, is 2.4 seconds. And then the height h is equals to 34.8 meters. And this is the answers. Now, if you use your calculator, you have comment about it. You just can't have the answer. So you could, for instance, write like this. Use calculator. Draw graphs, because that's what you did. And then calc maximum. That's enough for getting all points on this exercise, but you have to do what you did, so we understand that you have realized it and not just guessed the answers. Okay, this was the A question. The B question, and it's very bad formulated, and it's my fault. I should have looked for it more. It says here now that unfortunately Emil's dad is in the wrong place at the wrong time and gets the stone in his head. Emil's dad is 1.80 meters tall and stands on the ground with his when he hits by the stone. So that's very bad. I hope you understand it still from the context what you're supposed to do. How long does it take for Emil for the stone to be airborne before it hits his dad, should the question be? Well, you know, you don't get any grades on this. It's just for a test, so it's no problem. So what you will understand is this. The height of the stone is given by this formula. That is 6,0 plus 24t minus 5t squared. And the question is, at what time is it at its height 1.80? Because that's how tall Emil's dad is. That's his position of his head. The height of his head is 1.8 meter up in the air. If you write this down, you will get 1 point. If you solve the equation, you will get the second point. But here as well, you can use your calculator, and I will show you how to do that. So we have this, the height. Then I have to go to y equals 2, and I have to insert another function. And that function is y equals to 1.8, and enter. And then I draw the graph. And you